Hi guys, welcome you all to my channel Explore Edu to Teach.
The next topic that we'll be covering in signal and system is Z transform and its properties. It is one of the most important concept in signal and system and one of the most famous concept that will be used in other applications as well. Talking about the university exam as well as the competitive exam, Z transform is one of the most probable topics from which questions are always framed. So please make a note of this topic. The notes are present down in the description box. So please download it from there. Do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram to get all the updates of whatever videos are going live on YouTube. For all the formula sheets, for all the summary videos which are constantly uploaded on my Instagram page as well. The links are there in the description box below. So basically today we'll be dealing with the Z transform introduction, the definition and the formulas, and about the different kind of ROC and the region of convergence of Z transform. So starting with the Z transform. So what is Z transform actually? So like all other transforms like the Laplace transform, the CTFT, DTFT, we have the Z transform as well. So Z transform is a transform technique where a discrete signal and systems are analyzed in frequency domain. That is, Z transform is basically applicable for a discrete signal x of n. It will not be applicable for x of t. It will be applicable for x of n. So Z transform is basically a transformation technique which is applicable for discrete signal and systems and are analyzed in frequency domain. So basically we have x of n. The Z transform will be x of z and it is applicable for discrete systems only. Where signal becomes a function of complex variable, z is equal to u plus jv r e raised to j omega. Where u is the real part, v is the imaginary part, r which is given over here is equal to square root of u square plus v square, and omega is equal to tan inverse of v by u, and try to find out what it is. So basically Z transform are characterized by Z plane, which is a plot of real versus imaginary terms. So if you see, you have the real value, that is u, which is present over here. The imaginary value is given as v, and we have this circle having radius r. So just talking about Z transform. So Z transform is basically a transformation technique in which discrete signal, not the continuous time signal, discrete signals are converted into the frequency domain, that is the x of z domain. Next you have z is equal to u plus jv is equal to r e raised to j omega. R is equal to square root of u square plus v square, and omega is equal to tan inverse of v by u. Z transform can also be indicated with the help of a circle, which is the ROC, having u as the real axis, jv as the imaginary axis, and we have the radius of r1. Next, we have the definition of Z transform. So basically, x of n is a discrete signal, x of z is a transform signal of x of n. Hence, x of z is given as summation minus infinity to infinity x of n z raised to minus n. Please make a note of this formula. It's a very important formula in Z transform. In fact, all the numericals in Z transform will revolve around this formula. Modifications will be done to this particular formula depending upon the various conditions. However, the base formula will remain this. Hence, I repeat, Z transform is basically a technique in which you are going to convert the discrete time signal into frequency domain. It's a kind of circle in which you will have real and the imaginary axis, and the radius will be given as r. I hope I'm very clear with that. Also, the x of z is given as summation minus infinity to infinity x of n z raised to minus n. Now what happens is that if I just consider one-sided transform, okay, which means from 0 to infinity, like we had from minus infinity to infinity, right? So when I just talking about one-sided transform, it's going from 0 to infinity, x of n z raised to minus n. I hope I'm very clear to you. The next thing that we have is about the ROC. The ROC is basically region of convergence. So what does region of convergence mean? ROC of x of z is those set of values of z for which x of z attains a finite value. So there are different kind of ROCs that we'll be talking about over here. Just try to understand what do you mean by it. Finite duration right-sided causal signal. Hence we have x of z summation 0 to infinity. If you know the basic formula, it says minus infinity to infinity. But when I talk about finite duration right-sided causal signal, the x of z is given as 0 to infinity because we are starting from 0 to infinity, x of n z raised to minus n. Now n is 0, 1, 2, 3, so on and so forth. So you have a0 z raised to minus 0, a1 z raised to minus 1, a2 z raised to minus 2, so on and so forth. Hence my x of z takes the entire z plane except z is equal to 0, because if I put value of z is equal to 0 over here, this x of z will become undefined because this z will go in the denominator and something upon denominator will always be something upon 0 will always be undefined. Hence there are 6 type of ROCs. One ROC is a finite duration right-sided causal signal in which we have x of n given as a0, a1, a2, a3, so on and so forth, in which my a0 is the first value. Hence you're starting from 0 to infinity, x of n z raised to minus n. Hence I have a0 z raised to minus 0, a1 z raised to minus 1, a2 z raised to minus 2, wherein my x of z will be my complete z plane except z is equal to 0. Next you have finite duration left-sided anti-causal signal, in which what happens is that my a0 is 0, but I won't have right side values, I will have left side values. Hence I have from minus infinity to 0. As I told you, the basic formula says from minus infinity to infinity, but in the first type we had right sided, hence I was starting from 0 to infinity because this arrow indicates 0th value. In the second case, we have 0th value over here and all other value will be towards the minus infinite range. Hence I have minus infinity to 0, x of n z raised to minus n, in which we have a0, a1 z raised to minus of minus 1 will be 1, a2 will be z raised to minus of minus 2 will be 2. Now what happens is that why is this value n minus 1, n minus 2, and minus of minus 1 becomes 1, minus of minus 2 becomes 2, because we are towards the left hand side. Hence I have 0, minus 1, minus 2, so on and so forth. Hence it takes the entire z plane where z equal to infinite is not defined, because if I put infinite over here, my x of z will become undefined. Similarly, I have finite duration two-sided, in which what happens is that I have both the sided value. Hence in this case I will be taking from minus infinity to infinity x of n z raised to minus n, in which I will start from minus infinity to infinity. Now what happens is that you have z raised to n is minus 2, right? N is minus 1, n is 1, n is 2. Hence you have a2 z raised to 2, a1 z raised to 1, a0. Again you have a1 z raised to minus 1, a2 z raised to minus 2, because this is the 0th value, this is minus 1, minus 2, this is 1 and 2. In such a way you will get the entire equation. So the first type we had, so the first basic formula is minus infinity to infinity x of n z raised to minus n. In the first type we had starting from 0, but the right hand side becomes completely minus, like 0, 1, 2, 3, hence we have 0 to infinity. In the next type we have 0 and towards the minus infinity, hence we have minus infinity to 0. In the third type we have minus infinity to infinity, hence we have total value which we have 0, 1, 2, minus 1, minus 2. Infinite duration right sided causal signal in which you have x of n, a raised to n, u of n. Now if I say about u of n is only defined from 0 to infinity, and then you have a of n, z raised to minus n. Therefore 0 to infinity, a z raised to minus 1 the whole raised to n. Why? Because u of n starts from 0 to infinity. Now if I just try to put the series, it is 1 plus, because this expansion will be given as this. Just try to reduce it, because the entire expansion will be given as 1 upon 1 minus a raised to z minus 1. Therefore z upon z minus a. Since it's a causal signal, we'll have mod z greater than mod a, where a indicates the radius of this particular circle. Next I have infinite duration left sided signal in which you have x of n is equal to minus of a raised to n, u of minus n minus 1, in which you have z upon z minus a, in which mod z is smaller than mod a. Now the entire circle is basically the plot in which you have mod z given as smaller than mod a. Hence it is the inside part. And here if you see, I have z upon z minus a plus z upon z minus b. I can consider mod z value greater than a, so this becomes my causal. Mod z value smaller than b, so this becomes my inside thing. Hence I have greater than a and smaller than b, a non-causal signal. So what you have to actually remember is, to be honest, is the first basic formula, in which as I told you, this is the most important formula, in which you have minus infinity to infinity x of n z raised to minus n. Now finite duration signal mein, the first thing is you are starting with 0 towards the finite side. Hence you have 0 to infinity x of n z raised to minus n, wherein you have this particular expansion, and it will only be defined for all values except z is equal to 0. When you are towards the left hand side, the expansion will be this, and it is defined for all value except z is equal to infinite. Finite duration two-sided signal in which you have left, right, everything. Hence I have the z transform is defined for all the values except z is equal to 0 and z is equal to infinite. Then we have the infinite duration right-sided causal signal in which you have z upon z minus a, where mod z is greater than mod a. The infinite duration left-sided anti-causal signal in which you have mod z smaller than a. So if you see over here, when you have a raised to n u of n, remember the z transform is given as z upon z minus a with mod z greater than mod a. And when your x of n is given as minus of a raised to n u of minus n minus 1, it is given as z upon z minus a only, but when mod z is smaller than mod a. That is the inside part. And then you can have a combination of greater than and smaller than both. Okay, so let us try to see a numerical on it, and let's try to see how do we solve this particular numerical. So the first question says, find the z transform and the ROC of the following discrete signal. X of n is given as this. So what is my standard formula? X of z is equal to minus infinity to infinity, but in this case I am starting from 0, hence I have 0 to infinity x of n z raised to minus n. Therefore I have 3 plus 2 raised into z minus 1 plus 5 into z raised to minus 2 plus 7 into z raised to minus 3. Hence my z transform is this value, and the ROC is defined for all values except z is equal to 0. Similarly, you have another signal in which you will have x of n given as something raised to n u of n plus something raised to n u of minus n minus 1. So the z transform of x1 of n is x1 of z, x2 of n is x2 of z. So I am taking this as x1 of n, this as x2 of n. The corresponding value will be x1 of z and x2 of z. Hence my combined z transform is x1 of z plus x2 of z. The x1 of n is given as a raised to n u of n. Therefore, you have the value, if you remember, of a raised to n u of n is given as z upon z minus a. Therefore, it is given as z upon z minus a, that is z upon z minus of minus 0.25 is z upon z plus 0.25. Hence, my mod z value is greater than 0.25. If you see over here, the formula says the same way. A raised to n u of n, that is z upon z minus a, mod z greater than mod a. Similarly, you have a raised to n u of n, you have z upon z minus a, where mod z is greater than a. Similarly, you have the next formula, which says a raised to n u of minus n minus 1 is minus of z upon z minus a. Hence, you have a raised to n u of minus n minus 1 is given as minus of z upon z minus a, that is 0.5. That is, your mod z is smaller than 0.5. Therefore, the combined ROC is this plus this, wherein my mod z is greater than 0.25, but my mod z is smaller than 0.5. This is the most important formula. I hope I am very clear with you with all the concepts. I have tried my best to make you understand the concept. So basically, the Z transform is over here. The formula is very important. The different kind of transforms, and I've tried to apply this formula which I've shown you over here onto these numericals, which are asked in GATE paper also, and which will also be asked in your university exams. So please make a note of it. If you like the video, please share it to as many people as possible. Subscribe to my YouTube channel, hit the bell icon so that you get notified every time a new video goes live. Follow me on Instagram for all the updates. Thank you so much, guys. God bless.